Hello, Mr. Aaron, Mr. Ryan. Okay, so today we want to talk about how to check if a graph, this is given this kind of data structure to represent a graph like, and we want to find out if this is a tree detection algorithm. Okay, this index means 0, 1, 2, 3. Okay, so we have 4 nodes labeled 0, 1, 2, 3. So look, 0, the left of a 0 is 1, okay, 1. The right of 0 is 2. Okay, the left of 1 is when it's minus 1, it means that it doesn't have the kid. The kid is null. Okay, so we skip 1 doesn't have the left tree. Right, one of the one's right is none. Right. 2, the left of the 2 is 3. The right of the 2 is nothing. Okay, and then 4 here, the left of 3 is nothing. The right of 3 is nothing. So it's at least a tree. Given this, okay? Yeah. Yeah. Look, the left of 0 is 1. The right of 0 is 2. The left of 1 is minus 1, which means nothing. The right of minus 1 is minus 1 is nothing. The right of 1, okay, is not minus 1. The left of 2 is 3. The right of 2 is nothing, minus 1, okay? And the 3, the left of 3 is nothing. The right of 3 is nothing. So is this a binary tree? Is this a tree? Very obviously. Is it? This is not a trick question. Is this a binary tree? Yeah?
Yeah, maybe.
What do you mean maybe?
Yeah,
Yes or no?
because the root doesn't have any number in it.
Oh, okay. Okay, good point. Okay. How about this? Yeah? Yeah, it's a binary tree. It's a tree. It's a binary.
No, because one of them has an arrow, it's 0 to 1.
Ah, okay. You're quite picky. Okay. So how about this?
No, because one of them got a fully circle.
Okay. So don't worry about the notation. It's just 0, 1, 2. There's 4 nodes connected by this way. This is a binary tree. It's a tree. It's a binary tree. Look, left and right. Okay.
No.
So in order to be a tree, what kind of thing we are looking for? In order to be a tree. Anybody?
Leaves.
Come on.
Leaves and
Come on.
it needs to be connected.
Connected, okay, well done.
Wood.
Connected in one piece, yeah? You can't have like another one here. That's not a tree, okay? These are forests, okay?
Okay, so, and also it can't have cycles.
Cycles, well done. So we can't have any edges.
cycle.
We can't do this, right? This is not a tree. This
It
is one,
needs to be
okay?
a cycle.
Anything else?
One root.
One root, okay? So it's kind of like if you have 2 roots, it means that, if it means not connected, so it's kind of here, okay? But I put it here, right? It's 1 root, okay? Well done. Any more? No? I think, okay, so we're talking about this undirected graph, yeah? Undirected graph.
It needs to be clean.
And actually, it has directions, yeah? From parents to the kids. It's not parents. Directed graph,
tree.
right? Yeah.
What
Sorry?
does that attach to?
No, okay. So yeah, so how do we do this? Yeah. So first of all, you mentioned about the root. So the idea is that we need to find the root first, right? So if we find the root, then we can do this breadth search or depth search, right? What's the breadth search of this tree? Anyone? This is easy question. What's the depth search?
0, 1, 2, 3.
Okay. What's the what did I say? Breadth search, yeah. What's the depth search?
0,
0, it's the same, yeah? It's the same, okay? 0, 1, 2, 3. 0, 1, 2, 3, okay? The breadth search, level by level. Depth search, you go down as deep as you can, and then if not,
No,
you go back.
breakfast search, you use food.
Okay. We are given these 4 nodes. How do we find the root? Possibly. So we need to count one thing. What is this? The number of what kind of edge is coming. What does it call? In degree. Where down? In degree. So this is the number of, this is the edges that going in. So if we go through these, then we find that in degree. First of all, we go find out in degree equals 1 or equals 0, then that's a root. Yeah. If we find there are 2 roots or 0 roots, what does it mean? It means that we can just return, right? Because in in order to be a graph, to be a tree, it needs to be exactly having one
It needs to be exactly.
one node that doesn't have any integrate, doesn't have any edge coming in. Okay, and then we can do this breadth search, depth search, and then we can find out the number of nodes. The number of nodes visited is exactly n nodes. Okay, define tree detection. We have this left and right. Okay. So we are given this left and right. First of all, we need to get this n. N is the number of nodes, right? Length left or right. It should be the same, yeah. Both arrays should have the same size, okay. And then we can count the number of integrate edges. So let's do it in the data, okay. In the data equals default. This is the integrate, right? Default dictionary int. Okay, and then we go through for I in range n, right? So look, if the left I not equal -1, right? There's no point to count the integrate of nothing, right? If left I not equals 1, then data array, Ryan, left I plus equal 1, okay? Okay, look.
You're the one.
If right,
You're a man.
what am I writing here? If right I not equals -1.
You're writing if right eye is.
Okay, and right I minus. Eric, can you tell me what I'm doing here? From this line here to here. Guess. What does it mean? Plus equal 1. We are counting what? Yes, I know data is a dictionary, so we are iterating over the nodes, and then because left I is the left child of the node I, and then we increment this by 1. What does it mean? The number of integrate. Yes, we are updating the integrate. Well done. Okay, integrate here. So now we want to find out the root. Yeah, so the root will be equal I for I in range n. If what? So we have this node from 0 to n minus 1, but we want to check if the data I integrate equals 0, right? Look here, right? This is the root, right? But this may be empty, or it may have more. We may have more than one root, right? Look, this is the list, yeah. For I in range I, if data I is the integrate of I equals 0, right? Am I right? What does this equal 0 mean? Data I equals 0. Anybody? Come on, I will just say data I equals 0.
So
What's data I equals 0? What does it mean?
default dictionary equals
The integrate is
nothing.
it's nothing. So there's no edge going in. So that's a root. Okay, so look, if the length of the root is not equal 1, then we need to return what? If the root, if we find more than one root, or if we find no root, right? If we find no root, what does it mean? There's a cycle, right? 0, 1, 2, something like that. There's no node. Each node has some integrate, right? Yeah. So if it's 0, it means this kind of situation. If it's more than 1, it means what? Something like that, right? Right? If it's more than 1, so these two are not trees. So what should we return? Come on.
Nothing.
False. Okay. Okay. Yeah. So now we know to find the root. Root 0 will be the root. Yeah. Then we do this breadth search here. Or another way we can do this. We can turn this. We can turn the root is a list. Root is a list, and we turn it into iterator root. And then we do this next, then you give us the root. This is basically the same thing, okay? We're turning the list into iterator, and then we do the next. This is the syntax of the, fancy syntax. But as long as we know it's only one element here, so then we can do this root 0, okay? And then we do this breadth search. Okay, breadth search. What kind of data structure can we use to implement breadth search, Ryan? I think you know this question. Breadth search.
Huh?
What kind of data structure can we use to implement Q? Yes, and in
That's why I
Python.
did Q.
Well done. Wow, good job. Okay, Q equals DEQUE. First of all, we put the root in. Okay, root 0. Okay, put the root 0. Or you can do this. Okay, it's the same thing. And then we need to have this sin equals set hash set. Okay. Then YQ easy. Current equals Q dot pop left. Okay, and then if current in sin, right? We have seen this before. Then we need to return false, right? Why is that? Because look, if we have seen this node before, that means there's a cycle, and right? So that's why we seen it. So we return false. Otherwise, we need to put it in a sin table. What's sin? It's a hash set. It's a notebook. Okay, sin dot add current. Okay, then if what? If left current not equals -1, then we push this Q dot append left current, right? Then if right current not equals 1, then Q dot append. I don't have enough space, but you know what I'm talking about, right? Okay, that's just the breadth search here. Here is the breadth search. BFS. Here, this is counting the in degree, updating the in degree, okay? Updating the in degree. In degree of the nodes, okay? And then after, if all are these, then we need to return length of the scene. We want to find out the nodes we have visited is equals to the n, right? This is the number of nodes we given in the graph, right? Everybody, come on. Yes? Any questions so far? Any questions so far? No? Okay. Okay, so one last question. Can you tell me how do we check the node has been visited or not? How do we check? Which line is the data structure we use to check, to put the nodes that we have visited? Come on, it's very obvious here.
Okay, let me see. Scene.
Scene, and this is the
Set.
hash set.
Set.
Stop.
Set.
Yeah.
Set. Set.
Okay.
Set.
Here, look.
Set. Set.
Okay,
Set.
that's it.
Set.
Okay. If everything's seen, then we visit it. Okay. And then if not, then we put it in a hash set.
Set.
Okay, that's it for today. Bye bye. Bye bye on. Okay, that's it for today. Bye bye.